Welcome to our workshop. My name is Sherry Fang. So today I'm the host for this workshop. So as we know that the decentralized storage become more and more popular nowadays. So in the last year, the fourth season, so a popular project, Falcon both a wave of heat for decentralized storage. After that, and more people get to know what is IPFS. So, but we found the dark horse, which is Crust. So today we have invited the CTO of the Cloudera, which is Luke. So Luke, can you tell us what is the decentralized storage?
Yeah, thanks, Sharing. And please let me have a very brief introduction of myself. And hey, guys, I'm Luke. As Sherry said, I'm CTO of Cloudera, and we are the one of Crust Global team. And we focus on building the GPOS, which is one of the Crust protocol stack consensus protocol of Crust Network. And we help Crust pass two phases testnet. One is the profit arc, and the second one is the Maxwell. And now Crust already launched its mainnet, and actually already launched 1 month. So thanks, Sharon. And I heard about your first question is what is the decentralized storage? And here is my opinion and my thoughts about the decentralized storage. So unlike a centralized server operated by a single company or an organization, decentralized storage system consists of like peer-to-peer network, right? And with the user operators who hold the portion of the overall data, and it may create a resilient file storage sharing system like the BitTorrent network we've already used like 30 years, right? And this can be in a blockchain-based application, like to storing the application data inside a block, or any peer-to-peer based network. So any blockchain can be considered as a decentralized storage network. We can store the data in block with our customized information. That's the decentralized storage. Like we store the colored coin information in Bitcoin OP return database, or all the smart contracts stored on chain in the Ethereum, right? But however, when it comes to store a large amounts of data, like we want to store a movie, or we want to store our slides, or we want to store this meeting in the real life, or that isn't what those blockchain was designed for, like the Bitcoin or the Ethereum. So the chain is like a steadily growing, like Ethereum. For example, Ethereum's chain data is around 500 gigabyte to 1 terabyte. So every node on the internet needs to be able to store all of the data. So we call it full node in Ethereum, right? But if the chain were expanding to large amount of data, let's say if we store a movie in Ethereum on chain, it may be growth like 5 terabytes of the blockchain data. Like that wouldn't be feasible for all nodes to continue to run. Like you can imagine if we want to sync up Ethereum's full node, let's say 5 terabytes, that would be a very terrible situation, right? So due to those constraints of we cannot store the data directly on chain, like in the Bitcoin or in Ethereum. So we need a different chain design for storing the large amounts of data in a decentralized way, right? So same with the blockchain, the decentralized storage needs to solve the consensus and the decentralizing problem. And the decentralized storage also needs to promise the data persistence. We call it incentive and the data retention. So we need to we need to promise the user this miners or this blockchain nodes store your data in a right way, right? So based on this thoughts, so two very basic ideas are coming out. So the first one is like, what if we expanding the block? So like we scale the block in a very large size, and then maybe we can store movie directly on chain. So we still store the data on chain in block and verify it with like regular transactions and blocks. Yeah. So the second idea is we store the data off chain and try to prove it with on-chain mechanism or on-chain, we call on-chain contract, right? So for the first idea, we can talk about later, but for the second idea, the decentralized storage needs a storing protocol, right? So for now, the most popular one is called IPFS. So IPFS is pretty similar as the BitTorrent we have used 30 years, and you can launch an IPFS client to join this network, to sharing file and access data through this protocol with just the CID. I can just share my screen to give you a concrete demo to talk about this, okay? And some of the browsers already support the IPFS protocol. Like I can just access my data using IPFS prefix, not instead of HTTP prefix, right? So I can just tag this URL with IPFS prefix, and I can just access. This is actually a website hosted on IPFS. So I can just retrieve this website using IPFS protocol and without anything, okay? So that's the basic idea I'm considering about the decentralized storage. So thank you, Shirin.
Okay, thank you, Luke. So just like Luke mentioned, the decentralized storage can have the many different locations, and then they can save the data that like companies provide or something like that. So it's also faster, and the more they have more capacities. So actually, except the Crust, there are some other projects in the decentralized storage. So can you tell us like what's the different projects are included in the decentralized storage?
Yeah, thank you, Shirin. There is several decentralized storage, we call D storage in short term. This D storage projects, like Ethereum divided the D storage projects into two categories, corresponding the idea I just mentioned last question. Is the first one is a blockchain based D storage projects. That's the only one we call R-Wave, right? Everybody's heard its name. And the second one we call contract D storage project. So we have Filecoin, we have Crust, we have Storage, we have Zero Chain. So, but this contract-based project, but it's based on the IPFS, the original D storage project are only two projects. The first one is Filecoin and the Crust. So that's like very popular or famous projects in the disk storage area.
Okay, okay, cool. So just like you mentioned that a way these storage Filecoin are under the IPFS. So but I think like Chia, Swarm, they are so like so many people they get to know this. So do you know like what's the difference between the different projects with Filecoin?
Yeah, actually, like Chia or BZT, we prefer to call it as a POC project. Like the difference between the POC and D storage, the root difference is like the POC, we cannot store the real users' data in their system or in their storage. But in this storage, we can actually store some users' data, but we can talk in later questions like what's the we can just talk about later. And for now, I just to divide it into Chia or BZZ or Swarm or some BZZ or Swarm, aka Swarm, into a POC, but they are not like these storage projects. Yeah.
Okay, okay. As we know that Filecoin is the other famous project which is under IPFS. So so a lot of people will compare like with Filecoin and the Crust. So do you have some like so what's the advantage compare Crust to compare with Filecoin?
Yeah. So that question can be seen as the difference between the Crust and other project of like decentralized storage, right? So we comparing Crust with other contract-based storage project. The biggest difference is we can compare both miner side and user side. So for the miners, we don't have any like super nodes in our network. So super nodes will like control all the operations and data movement in blockchain and validate everything that should be sent to a storage nodes. So examples for such network or projects are like Saya or Lambda or Storj. They have super nodes. Like if you want to be a storage nodes, you need to permit it by those super nodes. And Crust don't need Crust don't have like super nodes. So anybody can just join our network, start helping people storing data and get reward. Yeah, that's the first difference between Crust and those super nodes based this storage project. And the second one is Crust don't need some like serious hardware resources. Like we don't require high-end GPU or CPU. So like Filecoin's miner, they need to do a complex zero knowledge POST consensus calculation. So they need those high-end GPU or CPU hardware. So which could be like very expensive and for those miners to for their cost. So our hardware restriction is super low. Like even your iPhone can just join our network to helping store the data for the users. And that's the miners side, the big difference between like Filecoin or other these storage projects between Crust and those projects. So for the user side, we are actually an order-based network. So anybody want to store their data, all they need to do is place a storage order on chain. So after a couple minutes, the data will be confirmed on chain. I can just show you a very concrete example through the Crust. So very recently, our application team sentiment team developed an application app called Crust Files. Please wait a second.
Mm-hmm.
So yes, so currently our sediment team created an app called Crust Files and integrate several platforms here. Shows in a very strange way. Wait a second. Yeah, I can just log in with Crust account, and I can just upload any files here. I choose, and I don't know if you can say that's what I'm signing. Sorry, I just changed it. I just changed my network. Sorry, my network is pretty poor.
That's okay. So this website and the people can see all the data or
so the basic idea I want to show you is I can easily log in with my Crust account or any other Web3 wallet account like Ethereum, Polygon, Solana, and I can just store the data in just a few steps, and I can just confirm on chain in a very very soon. Yeah. This demo is I can show you later, but the idea is for the users, we are unlimited and free. Any user can just place storage order and they can quickly be confirmed on chain. Yeah. So but unlike other contract-based storage project, each storage order needs to be like other order-based storage network. They need to refund or renew the order to avoid this file to be expired, right? But in Crust, we're providing a mechanism called prepaid pool, and the user can add money to this pool to automatically renew the order. So user can like customize their storage duration with like more than 1,000 years, right? And so this page, so this page just show I can just very quickly, to upload a file.
Okay, I see. So users can use this website and to send the large data like video or like the video or like the picture to their friends or the different users, and it's much quickly than the traditional. Okay.
Yeah, and I just upload this icon and I can open it in a few seconds. And the important point is I can query this CID with chain state. I can just show you a very quickly. Like I just pass the picture, just upload and place storage order on chain. And it already has this one, 142 replicas already, like 142 IPFS nodes in Crust already store this data for you, right? That's the biggest difference between Crust and other order-based storage network. Yeah.
Okay, cool. I see. So Okay, so just like Luke mentioned, there are some differences between the Crust and the different projects, which are also under IPFS. And thanks for Luke for showing the advantages of the Crust. But as we know that there are some problems and some hard timing for people to use Crust or like feel efficiently. So can you tell us like what's the problem in the Crust right now and how can we solve these problems?
Yeah, thank you, Sherry. And like all the decentralized project and Crust providing an incentive layer beyond IPFS, right? And a very basic idea is we want everybody join our network to provide their storage space and earn money. That's so simple. Yeah. So like Ethereum mentioned in their decentralized storage consideration, 4 things we want to solve. So the first thing is data persistent. We call it incentive mechanism. That's the problem about how to keep or store or retrieve the data. Yeah, so that's the first problem we want to solve. And the second one is we call it data retention enforcement. So how Crust can make sure the miners actually store the data. That's the second problem. So the third one is we call decentrality, like decentralizing, to measuring the decentralizing of the network. So the first one we call consensus. So how to distribute our blockchain reward and maintain the network. That's the fourth problem we want to solve. Yeah.
Okay, cool. So as we know that for the Filecoin, so the users cannot save or share their real data to the Filecoin protocol. But for the Crust, it seems like people can exactly use the website or people can use the Crust protocol to send the video or something to their friends or to people right now. So what does Crust protocol and do, and how can they actually solve these problems?
Yeah, I made a slide to try to explain very clearly to our audience. So, so this is the brief idea about Crust protocol stack. So as you can see, Crust protocol stack divided into 3 layers and separated into the off-chain part and the on-chain part. Yeah, so the off-chain part, we call it MPOW, meaningful proof of work mechanism. So their work is periodically check the miner's local storage status and quantify the storage volume the miner providing and all the files the miner stored, and generate a signed work report to the on-chain. So in detail, I can show you this way. And the MPOW, once the user store the data through the IPFS, so the node can pull the data from users, and it will divide it into several pieces and store it locally. And this local data will sealed through a TEE sending process, and those sealed data piece can be challenged or can be quantified or can be proved the miners like indeed store the data. And those MPOW protocol will periodically sign a work report on chain. So that's the first layer, MPOW. So MPOW resolve the data retention the problem. That's solve how to make sure the miner actually store the data is through this protocol layer, right? And the second layer we call GPOS. That's our job. So that's Cloudarium do. So we provide a consensus. It provides a consensus and a blockchain reward protocol. In detail, it's the idea comes from the Polkadot's MPOS. So but it's different. Lines in we have like stake limit. So once the on-chain protocol resolve like Alice stored 500 gigabyte data, and their work report will be reported on chain. Once we received this work report, we will transfer this 500 gigabytes data into like 500 CRU stake limit for Alice, right? So once Alice got 500 stake limit, they can stake 500 CRUs. That's the fundamental of GPOS. But besides it, everybody can like guarantee stake, like vote to Alice. Like if I am Bob, I want to vote like 200 CRUs to Alice. That's fine. So we can using this mechanism to achieve a dynamic balance between the POW and the POS. Let's say if I am Alice, I provide 500 gigabyte data. I am minor, right? But I don't have any like CRU or tokens. But I can accept other token holders to guarantee to vote for my vote for me, and both Alice and other token holders can earn the money through this GPOS protocol. Yeah, that's the second layer of about GPOS. And the third layer we called DSM, Decentralized Storage Market. So this protocol only provide a single but most important on-chain interface we call place storage order. I can just show it here. The transaction and the market and this one. So all you need to do is place like a QM123 and to report your size like 14 megabyte, and maybe you wait a memo or not, and you just assign a transaction. Yeah, so that's the only on-chain interface the DSM provides. So with in detail, I can just go to this storing process. So once user place storage order, the node on Crust Network will pull the file from the user and seal the file and report on chain. So after the network received the miner's work report, and the user can just check the file status just on chain, like I just show you with this example, right? With this demo, yeah. That's yeah, this one.
Okay, Luke. So can you go back to the first page?
Yeah, sure. This one, you mean? The first page.
Yes. Yeah, the first page, please.
This one, the protocol stack.
Yes. So I'm confused about DSM and the GPOS. So can you tell us like what's the differences between DSM and the GPOS?
Yeah, sure. So GPOS is actually responsible for the consensus. It determined which node can be like be block authoring node, right? That's the consensus part. And GPOS also determine the reward protocol, which nodes I need to give them reward and how much money I need to give this reward, right? That's the GPOS part. So and also GPOS is actually a POS based consensus. So you can treat it as a proof of staking consensus, but with stake limit and guarantees mechanism. That's the GPOS. As for the that's GPOS. Am I clarify clearly about GPOS?
Yes, like almost understood.
Yeah, as for the DSM, that's another protocol layer. That's the application layer. So based on MQW and the GPOS, we can resolve the problems how to make sure the miner store the data. That's MQW, and how to make incentive mechanism. That's a GPOS, and consensus also the GPOS. And the application layer is try to resolve how end user like you and me wants to use this decentralized storage network, and what interface or what method they can access, right? That's DSM. So it only provides application interface called place storage order. That shows in this way. So if you want to use Crust to store your data, right? All you need to do is place a storage order. That's the DSM provide. Yeah. So you can treat it as application protocol. Yeah.
Okay, Luke. So thank you for your sharing, like all the logic corrects, and it's very professional techniques. So so if I were the company, so if I want to save my data and using the Crust protocol, so can I just take these steps and I can save my data in the Crust?
Yes, and I can just show you a very raw way to store the data. So if you are a storage user, you can use Crust with IPFS or without IPFS locally. So please wait a second. Yeah, that's the interface or UI for storage users to show the basic idea. So the first step shown in this one is I just add my website or add my file in the local IPS, but I can just upload to the gateway. So that's the first step. So I can just upload all my website using the folder. So upload. So I can sign a transaction with this one. That's the first step. Sorry, my network is a little bit slow. Yeah.
Yeah, I think the Wi-Fi is poor right now.
Yeah, please let me try again. Yeah, so that's the first step. I upload my website to IPFS gateway, or you can upend your website in a local IPFS. That's the first step. So the second step is I call the DSM interface called place storage order. Yeah, that's a transaction I need to send. Yeah.
So I have the other questions. So if someone wants to use the Crust protocol to send the data to their friends, do they need to cost some CRU or is all free?
They need to call some CRU to call because the place storage order is an on-chain transaction. You can treat it like this. Yeah. So without CRU, you cannot send a transaction, right? Yeah. So
it makes sense.
Yeah. So the transaction I just sent successfully, and I can access my data, my website that's the in this URL. So that is my website. Yeah. I just show you. I just show you. The first step and the second step and the third step. I can just access my website, and all you can see this one is I just place storage order and store it through the gateway, and currently it already have 180 replicas. That means there is already has 118 IPFS nodes store this website for me. Yeah, that's the steps you all the companies or the end users can store their data. Yeah.
Okay, cool. So thank you, Luke, for sharing all the techniques and how to use the Crust protocol to us. So as we know that there are more and more people start to talk about the metaverse, and they think maybe metaverse is the future. So we have here about like Facebook want to be a metaverse company in the 5 years in the future. So can you talk about like how could Crust to support in the metaverse in the future, or what's the purposes for the Crust in the future?
Yeah. Thank you, Sherry. And I can see that metaverse is a super hot topic these days. Currently, actually, Crust help some Web3 projects as their storage layer. So those are the things we have already done from so far. So the first category called dApp hosting, and now we have I can just copy it here to show. Yeah. The first one is Uniswap already using Crust as their interface storage CD. Yeah. Already take Crust into their daily deploy process to store their dApp on Crust. That's the first case, Uniswap. So Liquidity also using Crust as their storage layer, and IPFS stocks, and also Polkadot apps, and of course the Crust app itself are already using Crust as storing their websites. So the second one is close to the metaverse. That's NFT. So now we have a minting platform. That's minting platform. That's the application developed by our Europe team called SwitchSwap. And with this SwitchSwap, you can mint your NFT with Crust, store your NFT and NFT metadata using Crust, and mint it on Polygon, which is also our partner. And another thing is meta storage we call Bluna. sorry, this one, the Luna, and that's it also it's also a very important player of metaverse. They store their NFT data on Crust. So that's the NFT side. And also we have some file storage cases. Like the first one is a decentralized YouTube project. We call it SoftBay. And that's also a Crust grants project that all of their videos are stored in Crust. That's a decentralized YouTube SoftBay. And the decentralized DocuSign, we call it Sky Kiwi. Yeah, that's Kiwi sign. That's a decentralized contract sign, DocuSign. They stored all of their documentations on Crust. So, and also we create an application for Polkadot. We call it Polkadot files, and you can log in with your Polkadot account and storing data on Crust. And also we launched several platforms so far, and we have our cross-chain storage solution, and with Polygon, Near, and Aaron, and Moonbeam, and of course on Moon River now. And so we can see decentralized storage is designing for serving the whole Web3 world. So especially the metaverse, as Sharon, you mentioned. So currently all the Web2 companies are dedicated to develop their metaverse productions. Like you mentioned, Facebook demos the virtual meeting, right? The TikTok help their creators publish the NFTs. And even the Travis Scott got his virtual concert, right? So however, the metaverse users don't want to store their data in a single company. Like we don't want to store the metaverse data in Facebook or Google or Microsoft. So all of the data needs to be stored in a decentralized way, right? That's what Crust future, like we want to provide the fundamental storage layer of metaverse. Yeah.
Yeah, so as the point, just like Luke mentioned like that. So just like a lot of data and about like the game company, they created a lot of data. They need some places for the storage. So, and they don't want to put their data in the traditional data saving like Amazon or something like that. So at this point, the Crust and the IPFS will be I think it's the big idea, and it's the big chance for the decentralized storage in the future. That's because there are a lot of storage and the data they want to save in the decentralized storage. So I think that might be the big chances for the IPFS.
Yes.
Okay, so do we have the questions of the audience, or? Okay, so I found a question. The Chin Chu Wang, and she asked like, what's your advantage over IPFS or AWS? So can you talk about like this?
Yes, sure. Actually, we are the IPFS based network. So all of the advantage advantages of IPFS is our advantages. Like you can just store locally, but access everywhere. That's the biggest advantage of IPFS. But comparing with AWS storage, I have article which is calculated by our Singapore team, and I can just show you. Sorry, I just found it. Wait a second.
Okay.
Yeah, so
No,
this article. Yeah, so in this article, it comparing Crust with the traditional AWS S3. The most important one is the cost, right? And they just calculate the cost. In AWS S3 service, they need like cost 9 cents per gigabyte, but for Crust, you can just like this one. Yeah, I can just show you this way. It's super cheap. It's actually like 10 times cheaper than the traditional AWS S3 service. Yeah, that's the biggest advantage comparing with the traditional blob saving service. Yeah.
okay, so thank you for Luke's sharing. So I think there's no more questions for our workshop. Yeah.
Yeah.
Okay.
Thanks, Shirin. Yeah.
Okay,
And,
so thank you guys. Like, thank you everyone have watched our workshop. So I think what's the topic of the next channel?
top of next, I'm sorry.
I think the next topic should be the ecosystem and the cases for the next workshop.
Yes, we can talk in the next workshop about the ecosystem of Crust. Yeah.
Okay,
Thank
so
you.
guys,
Thank you, guys.
yeah, so guys, if you are interested in the next topic, you can just follow us and follow the channel.
Yeah, please keep following us. Thank you.
Okay, thank you, Luke.
Thanks, Shirin. Have a good day. Bye-bye.
Bye-bye, have a good day.